Okay, so a medium, I think they're a medium, not a median. There's a mediator. That's someone who like helps to make two different parties come to agreement for something, right? So a median in a triangle is a segment from a vertex to the midpoint of the opposite side. Okay, so we've got midpoint happening again. Mid-segment was finding two midpoints and connecting it. A median, we're going to find one midpoint and connect it to a vertex. What's the vertex of a triangle again? The corners, right? The corners of your triangle would be the vertices, your vertex. Okay, so on this triangle right here, can you guys measure the bottom side? So this side right here, either use centimeters or inches, whichever you prefer. Find the halfway point of it, and then put a dot. Find your halfway point, put a dot. Let's put single tick marks on the right and the left, just to give further proof that that's the middle, because the right and the left are the same. And then using your ruler, you're going to connect that midpoint up to the opposite vertex and make a line. And now you just constructed a median. Okay. The only thing I care about with a median is that this point down here is a midpoint. And what does a midpoint get me? The left equal to the right, right? I get two congruent segments down here at my midpoint. So that's the only thing I really care about when I'm told that something is a median. Alrighty, everybody got that? Can you do the medians of the other two sides? Why don't you practice? Find the midpoints of the other sides, connect them to the opposite vertex. Find the midpoint of the third side, connect it to its opposite vertex. Can you get all three medians in there? See if you can do it. And so if you did it correctly, what should happen with all three of your medians? They should intersect. That's called a point of concurrency. Not that you need to know this, but a cool part about this point, it's the center of gravity of the triangle. So if you had a triangle and you created all three medians and then you balanced it at that point, it would be the balance point. Okay, so that's one way you can check that you are accurate in your measurements. On your quiz, you may potentially have to do all three medians, or you may just have to do a median from one base to an opposite vertex. Or you might have to do both, okay? But again, the only thing we really care about is that these are midpoints, which tells me that this side is equal to that side because they're both halves. Yes, Luke?
Wouldn't we only have to find like two of the midpoints and do that only two times to find the center of gravity? Technically,
yes, because you could see where you would hope that the other one would be there. The third one's there to kind of check to make sure it is accurate, right? Okay, all right, so let's move on to the actual examples. So if GT is the median, so because I'm told that that's a median, I know that this FT is going to be the same as the ET. So just get in the habit of putting those tick marks there to remind us that the left equals the right. If TE is 8, what is FT? 8. So what is F to E? 16. Perfect. So F to E is 16. Okay. Does everybody see that? So FE equals 16. Final answer. Wait for everybody to get there. On to the back. Again, GT is my median, so that tells me my left is equal to my right. if f to e is 24, then f to t is half of that, so 12. Good. Nice. Now can we throw some algebra into the mix?
Yes. I know how this works.
Okay, everybody's good with this one? All right, so on to the next example. Again, GT is the median, so that means my FT is equal to ET. If FT is 2x plus 8, so I'm going to label that. And if ET is 3x minus 7, so I'm going to label that. What should be true about those two expressions? They should be equal to each other, right? So can I just set them equal to each other and solve for x? Sure. Okay, so left equals the right. So my smallest x term is over here on the left. So let's subtract 2x over. So now we get 8 is equal to x minus 7. Adding 7 to both sides. Gets us, what is that, 15 is equal to x. I'm not done, because what's it asking us to find? FE. Well, we got to plug in the x, not just add 15. I got to plug in x for 15. So let's figure out what FT is. So 2 times 15 is 30, plus 8 is 38. Technically, the other side should also be 38, but let's check our math and make sure it is 38, because if I don't get 38, then I solved it wrong. 3 times 15 is 45. 45 minus 7 is 38. Yeah, so I know I did it right. So the whole length is how much? What is that? 76? So FE is equal to 76. Okay. Can I make a new problem that's not on there? You guys have space somewhere? Got some white space? Well, actually, before we do that, we'll do the last one, then you can see where you have space on that page. So let's move to that bottom one. So BD is a median. That means D is the midpoint. So what should I do with 2x plus 3 and 4x minus 5? Set them equal. So 2x plus 3 equals 4x minus 5. Subtract 2x from both sides. 3 is equal to 2x minus 5. That's my next step. Add 5 over to the 3. So 8 is equal to 2x. So x is equal to 4. But now I'm asked to find AB, which is over here.
Do you plug,
So 5 times 4 is 20. So AB is equal to 20. All right, do you have space somewhere on that page yet?
yeah.
All right, I'm going to make up a new problem here that's similar to the previous one, but a little bit different. Is everybody good? I can erase this? Okay, so let's make the same triangle. We'll use that same GT triangle. What was it? GTFE. So if FT, let's say, is equal to x plus 6, and F to E is equal to 3x minus 1, how would you solve for x? Well, are they equal? So FT...
Oh, you double x plus 6 and then set them equal.
Yeah, so FT is x plus 6. The whole thing is 3x minus 1. So this does not equal that.
Or you could do like x plus 6 equals 1/2 of it.
You could, which would probably be uglier, right? Because I would have to then take half of 3x minus 1.
Yeah.
So I could double this and set it equal to that. So 2 times x plus 6 is equal to 3x minus 1,
Or just 2x plus 12 equals 3.
which is 2x plus 12 is equal to 3x minus 1. subtracting 2x from both sides. 12 is equal to x minus 1, so x equals 13. And then if we had to plug it in, we could plug it in for whatever we want to find, right? Okay, so be aware that they might not always be equal to each other. So you have to really think about, well, what is that? Is it the whole segment or is it just half the segment? Okay? All right, questions with medians before we move to altitudes?
No.
Okay, so altitudes aren't that complicated. When you hear the word altitude, what do you think of? Height. If you said to Siri right now, hey Siri, what planes are flying above me? Did you ever do that before?
No.
You should try it. Like it'll tell you what planes and their directional distance away from where you are right now. So you can see like, it is kind of, huh?
Isn't that creepy?
It is kind of creepy. Like what is flying above us right now? So altitude is height. So how do we decide how high something is?
You measure it.
So if I wanted to find the height of myself, would I take this and like put it on an angle and then like say, well, I'm 2 meter sticks away? Is that how I measure my height?
No.
I measure my height straight down.
Yes.
What do we call something that is straight down? Perpendicular. So your height has to be measured with a perpendicular line, right? I don't have Luke stand up there and be like, okay, I'm going to measure Luke, and then I'll like measure this way and
Well,
say,
I'm like 4
Luke,
meters tall.
you're 8 feet tall, right? He's
Yeah.
not. You do the perpendicular distance. Okay, so altitudes need to be the perpendicular segment
Where is that?
on the back, and I think it's fill in the blank. A perpendicular segment from a vertex to the opposite side. But then we have this condition that needs to apply for specific triangles or to the line that contains the opposite side. And that will occur on obtuse triangles, and we'll show you what that looks like. Okay, so the only thing I really care about altitudes is it's going to be perpendicular. So if this was my base right here, and I needed to construct the altitude, does everybody's ruler has a square corner? So we're going to call this a right angle. Some of the rulers I think are rounded. Are all yours square?
Yeah.
Okay, so we'll use this as our square for perpendicular. So I'm going to line up my ruler, make it flush with the base, keep moving until I hit my highest vertex, which seems to be right there. And then I'm going to drop a perpendicular line straight down to my base.
This is an awkward angle for me.
To show that it is perpendicular, what do? We put a square, a box. So the only thing I care about when I'm hearing the word altitude is I know now that this is a right angle. And now I've created 2 right triangles inside my triangle. Right? So if this is 90 degrees and this was 30 degrees, I could find this angle by subtracting them all from 180 and get 60 degrees. Right? So it gives me 2 right triangles inside of it. All right, so let's do the 3 constructions on the back. So can you do an altitude for this acute triangle? So make it perpendicular, line it up with your highest point, drop your line down, put a square. Challenge question. If this was an equilateral triangle, what do you think would be true about the median and the altitude? They'd be the same exact line.
Yeah.
Yeah, they would. So that altitude should fall at the midpoint. Okay, now let's go to a right triangle. Well, where is the highest point on my right triangle? It's up here. Well, if I make a perpendicular line to the base, what happens? Isn't it just the side?
Yeah.
It is. So when you have a right triangle, your altitude will fall on one of the legs of your right triangle. If it's obtuse, now my highest point's over here.
Do you just extend it?
This is where we have to extend the line because I'm like, well, this kind of looks like it's perpendicular, but I'm unsure. So we need to extend that third side with a dotted line. So put your ruler down there and then extend it out with a dotted line. Kind of go a little bit
What if I didn't do a dotted line?
That's okay. And then once you have your extension of your third side, then drop your perpendicular down to that extended side. So that's probably the trickiest one. It's making an altitude on an obtuse triangle. Then drop your perpendicular down as such. Okay? So medians, what do I care about the most?
Straight line, go straight down.
Well, that's altitude. A median, what do we care about the most?
Midpoint.
Midpoint. I care that it's the midpoint because why? The midpoint gives me two halves that would be equal to each other. Altitude, the only thing I care about is that this is what type of angle? A right angle. Good, which gives me 90 degrees. Okay, go ahead and get out